Advanced keys and addresses. In the following sections, we will look at advanced forms of keys and addresses, such as encrypted private keys, script and multi-signature addresses, vanity addresses, and paper wallets. Pay-to-script hash and multi-sig addresses. As we know, traditional Bitcoin addresses begin with the number 1 and are derived from the public key, which is derived from the private key. Although anyone can send Bitcoin to a 1 address, that Bitcoin can only be spent by presenting the corresponding private key signature and public key. Bitcoin addresses that begin with the number 3 are pay-to-script hash addresses, sometimes erroneously called multi-signature or multi-sig addresses. They designate the beneficiary of a Bitcoin transaction as the hash of a script, instead of the owner of a public key. The feature was introduced in January 2012 with BIP16 and is being widely adopted because it provides the opportunity to add functionality to the address itself. Unlike transactions that send funds to traditional 1 Bitcoin addresses, also known as a pay-to-public key hash, funds sent to 3 addresses require something more than the presentation of 1 public key and 1 private key signature as proof of ownership. The requirements are designated at the time the address is created within the script, and all inputs to this address will be encumbered with the same requirements. We'll abbreviate pay-to-script hash as P2SH. A P2SH address is created from a transaction script, which defines who can span a transaction output. Encoding a P2SH address involves using the same double hash function as used during the creation of a Bitcoin address, only applied on the script instead of the public key. Script hash equals RIPEMD160 applied to SHA-256 of the script. The resulting script hash is encoded with base 58 check with a version prefix of 5. Which results in an encoded address starting with a 3. An example of a P2SH address is 3F6I M1HM, which can be derived using the Bitcoin Explorer commands script encode, SHA-256, RIPEMD160, and base 58 check encode. Tip: P2SH is not necessarily the same as the multi-signature standard transaction. A P2SH address most often represents a multi-signature script, but it might also represent a script encoding other types of transactions. Multi-signature addresses and P2SH. Currently, the most common implementation of the P2SH function is the multi-signature address script. As the name implies, the underlying script requires a minimum number of signatures to prove ownership and therefore span funds. The Bitcoin multi-signature feature is designed to require M signatures from a total of N keys, known as an M of N multisig, where M is equal to or less than N. For example, Bob, the coffee shop owner from Chapter 1, could use a multi-signature address requiring one of 2 signatures from a key belonging to him and a key belonging to his spouse, ensuring either of them could sign to span a transaction output locked to this address. This would be similar to a joint account as implemented in traditional banking where either spouse can span with a single signature. Or Gopesh, the web designer paid by Bob to create a website, might have a 2 of 3 multi-signature address for his business that ensures that no funds can be spent unless at least 2 of the business partners sign a transaction. We'll explore how to create transactions that span funds from P2SH addresses in a future section. Vanity addresses. Vanity addresses are valid Bitcoin addresses that contain human-readable messages. For example, 1 love bp ... r33 is a valid address that contains the letters forming the word love as the first four base 58 letters. Vanity addresses require generating and testing billions of candidate private keys until a Bitcoin address with the desired pattern is found. Although there are some optimizations in the vanity generation algorithm, the process essentially involves picking a private key at random, deriving the public key, deriving the Bitcoin addresses, and checking to see if it matches the desired vanity pattern, repeating billions of times until a match is found. Once a vanity address matching the desired pattern is found, the private key from which it was derived can be used by the owner to spend Bitcoin in exactly the same way as any other addresses. You can no more easily find the private key of an address starting with a vanity pattern than you can of any other address. In Chapter 1, we introduce Eugenia, a children's charity director operating in the Philippines. Let's say that Eugenia is organizing a Bitcoin fundraising drive and wants to use a vanity Bitcoin address to publicize the fundraising. Eugenia will create a vanity address that starts with 1KITS to promote the children's charity fundraiser. Let's see how this vanity address will be created and what it means for the security of Eugenia's charity. Generating vanity addresses. It's important to realize that a Bitcoin address is simply a number represented by symbols in the base 58 alphabet. The search for a pattern like 1KITS can be seen as searching for an address in the range from 1KITS 11111 ... to 1KITS ZZZ ... There are approximately 58 to the 29th power addresses in that range, all starting with 1KITS. Let's look at the pattern 1KITS as a number and see how frequently we might find this pattern in a Bitcoin address. An average desktop computer PC without any specialized hardware can search approximately 100,000 keys per second. 1KITS occur at a frequency of 1 in 11 million and takes around 1 minute to search. 1KITS charity occurs at a frequency of 1 in 23 quintillion, which takes 2.5 million years to search. As you can see, Eugenia won't be creating the vanity address 1KITS charity anytime soon, even if she had access to several thousand computers. Each additional character increases the difficulty by a factor of 58. Patterns with more than 7 characters are usually found by specialized hardware, such as custom-built desktops with multiple GPUs. These are often repurposed Bitcoin mining rigs that are no longer profitable for Bitcoin mining, but can be used to find vanity addresses. Vanity searches on GPU systems are many orders of magnitude faster than a general-purpose CPU. Another way to find a vanity address is to outsource the work to a pool of vanity miners, such as the pool at Vanity Pool. A pool of this type is a service that allows those with GPU hardware to earn Bitcoin searching for vanity addresses for others. For a small payment, Eugenia can outsource the search for a 7-character pattern vanity address and get results in a few hours, instead of having to run a CPU search for months. Vanity address security. Vanity addresses can be used to enhance and to defeat security measures. They are truly a double-edged sword. Used to improve security, a distinctive address makes it harder for adversaries to substitute their own address and fool your customers into paying them instead of you. Unfortunately, vanity addresses also make it possible for anyone to create an address that resembles any random address or even another vanity address, thereby fooling your customers. Eugenia could advertise a randomly generated address to which people can send their donations, or she could generate a vanity address that starts with 1KITS to make it more distinctive. In both cases, one of the risks of using a single fixed address rather than a separate dynamic address per donor is that a thief might be able to infiltrate your website and replace it with his own address, thereby diverting donations to himself. If you have advertised your donation address in a number of different places, your users may visually inspect the address before making a payment to ensure it is the same one they saw on your website, on your email, and on your flyer. In the case of a random address like 1J7, the average user will perhaps inspect the first few characters and be satisfied that the address matches. Using a vanity address generator, someone with the intent to steal by substituting a similar-looking address can quickly generate addresses that match the first few characters. So does a vanity address increase security? If Eugenia generates the vanity address 1kits33q.zen, users are likely to look at the vanity pattern word and a few characters beyond. For example, noticing the 1kits33 part of the address. That would force an attacker to generate a vanity address matching at least 6 characters, expanding an effort that is 3,364 times higher than the effort Eugenia expended for her 4-character vanity. Essentially, the effort Eugenia expends pushes the attacker into having to produce a longer pattern vanity. If Eugenia pays a pool to generate an 8-character vanity address, the attacker would be pushed into the realm of 10 characters, which is infeasible on a personal computer and expensive even with a custom vanity mining rig or vanity pool. What is affordable for Eugenia becomes unaffordable for the attacker, especially if the potential reward of fraud is not high enough to cover the cost of the vanity address generation. Paper wallets. Paper wallets are Bitcoin private keys printed on paper. Often, the paper wallet also includes the corresponding Bitcoin address for convenience, but this is not necessary because it can be derived from the private key. Warning: paper wallets are an obsolete technology and are dangerous for most users. There are many subtle pitfalls involved in generating them, not least of which the possibility that the generating code is compromised with a backdoor. Hundreds of Bitcoin have been stolen this way. Paper wallets are shown here for informational purposes only and should not be used for storing Bitcoin. Use a BIP39 mnemonic phrase to back up your keys. Use a hardware wallet to store keys and sign transactions. Do not use paper wallets. Paper wallets come in many shapes, sizes, and designs, but at a very basic level are just a key and an address printed on paper. Table 8. Simplest form of a paper wallet, a printout of the Bitcoin address and private key. Public address 1424.62x. Private key 5J3M.JCN. Paper wallets come in many designs and sizes, with many different features. Some are intended to be given as gifts and have seasonal themes, such as Christmas and New Year's themes. Others are designed for storage in a bank vault or safe with a private key hidden in some way, either with opaque scratch-off stickers or folded and sealed with tamper-proof adhesive foil. Other designs feature additional copies of the key and address in the form of detachable stubs similar to ticket stubs, allowing you to store multiple copies to protect against fire, flood, or other natural disasters.